Bismillahirrahmanirrahim. Welcome back to my channel. Today I'm back with a video, and this video is it's a video on cryptography. I've made an entire playlist on cryptography, which started off from like AES, and then it went to like RSA and other algorithms like that. So I've been wanted to do DES, data encryption standard, for a while. And I actually made a spreadsheet on data encryption standard, and this was actually a predecessor of AES, Advanced Encryption Standard. This was used before 2000, before 2000s. So I made a spreadsheet on it, and I'm going to walk you through with the algorithm. How does this algorithm works? So for that reason, I made a spreadsheet on it. As you can clearly see, this is in the spreadsheet. I have a plain text and I have a key, and then based on this plain text and key, I'll have ciphertext. The first thing that I know about DES is that it's a 16-round algorithm, and that takes a data size of 64 bits. So it's a block cipher. So it's a block cipher that takes data of 64 bits, a block size of 64 bits. Once it takes a block size of 64 bits, then it performs substitution and then all the other stuff. So we're going to actually look at this. So actually I have two spreadsheets. We're going to look at both of them. This is the one that I'm going to work on. So the first thing that I'm doing in this spreadsheet is this. Then I'm converting this hexadecimal value, which is 16 bytes. So these are 16 values in hexadecimal, and I know hexadecimal is a 4-bit number. So when I have these 16 values, so 16 times 4 would give me 64-bit. So we're working on a block size that is 64-bit. So the first thing on this spreadsheet, what's going on, is that we are actually converting this plain text into, which is in hexadecimal, into bits. So I have given a bit number, like from 1 to 4, then 5 to 8, 9 to 12, and so on up till 61 to 64. So these are just the bit position. So for example, bit number 1 would be this, bit 2 would be this, bit 3, and bit 4. This is how and then bit 5, bit 6, bit 7, bit 8, and all that is happening as per this. So the first line is actually converting your plain text into bits. I don't want to actually manually do this, so I just did it using a spreadsheet. Now the second thing, as per the algorithm, I need to have something called an initial permutation block. So what these blocks, which are already predefined in the algorithm, what these blocks are doing basically, they are blocks like these, which is actually allowing us to actually convert to create a diffusion. So for example, this was part of the standard. So initial permutation, as per the algorithm, says that once you have your text, that you need to go through initial permutation. What initial permutation, as per the block, says 58, 50, 42. What that means, so just remember 58, 50, and 42. What that means is this. Take your 58-bit, all right? Take your 58-bit, which was in our case is going to, this is 56, so this is 57, 58. Take this bit and move it to position number 1. Why am I saying move it to position number 1? What is the position of this bit? So this bit, 58-bit would be now will be moved to position number 1. So this is exactly what we are doing. So if you want to look at this, this is my 56, 57. Now 0 is moved to position number 1 after initial permutation. So basically you're rearranging it based on the table, which is part of the standard. Same thing. Next, just quickly look at it. Next position, the next bit should be a bit number 50. So this new bit should be bit number 50. So this is 49. This is 49. This is 50. So bit number 50 is 0. Now that has become bit number 2. Now let's quickly look at the other one. Bit number 3 should be bit number 42. So bit number 42 in my here, so this is 41, this is 42, which is 1. This is going to be my bit number 3, and so on. This is how you're going to populate this in initial permutation. This is part of the algorithm. This is the first thing that I do to the plain text. Now the second thing I need to do is this. Once I have converted everything, so the first step was to convert your hexadecimal values into bit, which I did, and I actually numbered them as per 1, 4, 6, and all the way up to 64. The next is to use initial permutation. Initial permutation is done through the block, which is given as part of the standard. So let me show you, which is this. Now the next thing I need to do is this. Now let's look at round number 1. So let's start round number 1. Now the next thing I need to do is this. So this is a single round. So in DES we have 16 rounds. We have to do 16 times these operations. So in first round, what do I need to do? I would have my bit, first 32 bits on my left hand side and first 32 bit on my right hand side. So let me look at my spreadsheet. So all the way from 1. So we have already converted that after running initial permutation. Now we are working with this. So first 32 bits right here, these are called my left hand bits, 32 left bits, and these bits all the way up to 64, from 33 all the way up to 64, these are going to be my right hand bits. Alright, so far so good. So if you were to look at it, so these are your right hand bits and these are your left hand bits. As you can clearly see, now these right hand bits is going into a function, which is this. What does this function look like? This is how this function looks like from inside. Alright, so the operation will only take place on 32 bits which are on your right hand side. So these are the bits that will go through, that will only go to this block of expansion P. Now, as the name suggests, that we're going to input 32 bits in, and the output of these bits are going to be 48 bits. So it's means something is expanding. Alright, so in order for me to do that expansion, there is also a table which is part of the standard. So I'm just going to simply go here, and this is going to be your expansion P table. How am I going to use this table? Exactly the same way, just like we've been doing it. So we're going to run this operation here. Now, based on this, the first bit is going to be your 32nd bit. So 32nd bit as per this, now you don't need to. This 33 bit, now the bit number 33 is going to become your first bit, and bit number 64 is going to become your 32nd bit. So the first bit is going to be, as per the expansion table says, your first bit is going to be your 32nd bit. So this 32nd bit would become your first bit. And notice that where am I starting from? So I know these are 32 bits, and once everything goes through expansion P box, all of a sudden it will expand it to 48 bits. Hence I have 32 bits right here, 32 plus 16 extra bits, which I'm going to generate based on this expansion P box are right here. That's why I'm just using those extra lines from this, because all the operation is taking place on my right hand bits. So hence this is how I'm going to populate this rest of these lines. Once I have done that, once have I finished doing this, what is the next step that I need to do? Let's look at the round. The next step I need to do is this. So inside this function, expansion P is done. Now I'm going to XOR it. I'm going to XOR these 48 bits with my round key. So what these algorithm does, that it has one sort of like a master key. Like in our algorithm, this is a master key. And based on these master keys, for every single round, individual keys are produced. Alright, individual keys are produced based on this. So we're going to also look at it, because this key expansion algorithm is running on right hand side of my spreadsheet. So for now, just to understand round one, what we're going to do, we're going to see that we have already XORed everything together. So, all right, so far so good. Once you XORed it, I'm going to teach you how this expansion works. Once you XOR it, all right, this is the output that you would see. All right, once this is the output. Once you have XORed this with your round key, let's just simply do the exercise. On right hand side of my spreadsheet, this is actually the key generation algorithm, and this is the generated key for that round. So let's try to XOR it. Let's try to XOR it 1 bit by 1 bit. So let's XOR 1, XOR with 0, that would give me 1. 0 XOR with 0 would give me 0. 0 XOR with 0 would give me 0. 1 XOR with 1 would give me an output of 0. Can you all see this? This is how this is the output so far after expansion P and after you have XORed with the round key. Now the next step, as per the diagram, is saying that it needs to go through S boxes. All right. So X boxes, what it will do, as you can clearly see, it's taking 48 bits and it will give you 32 bits out, which means every single, so there are 8 of them, so it will take about 8 bits and it will spit out 6 bits. So every single box will take about 8 bits at a time, 6 bits at a time, and 1, 2, 3, 4, 5, 6, 7, 8, and 8 times 4, it will spit out 4 bits going through each single box. These S boxes are also part of the standard, and they are given like this. I'll show you in a form of a diagram like this. So for every single round, there are 8 different S boxes. So you need to take these. So these are the 8 boxes. So 1, 2, 3, 4, 5, 6, 7, 8. Now for round number 1, you're going to use all of them. You're going to use all of them in each round. Now what I'm going to do based on the diagram is this. Now based on this diagram, if you were to look at it, I have to take 6 bits at a time. Alright, I'm going to take 6 bits at a time and I'm going to map it. So how am I going to map it? Let's look at it. So now let's just quickly go here. So what I'm going to do, I'm going to pick up 6 bits. Alright. Now these two values. So the first, the most significant bit that you're seeing right here, and the least significant bit. You're going to pick up 6 bits at a time. Alright. 1, 2, 3, 4, 5, 6. So you're going to pick up 6 bits at a time. And now the most significant bit and the least significant bit. These are going to become your rows value. Alright, as you can clearly see, these will become your rows value. Show you. These are going to be your rows value. Alright, and then the values inside of this will become your, so inside this will become your column values. So as you can clearly see, so these are going to be your rows and these are going to be your column values. And it sort of does make sense because your rows are actually 2 bits and your columns are 4 bits, and the maximum you can get is about 15. So I hope you're getting it, what I'm trying to say. So as I can clearly see, so this is 1, 1. So 1, 1 is 1 plus 2 is 3. So this is 3, and inside everything is 0, 0, 0. So 3, 0. So that turns out to be 15 in binary. Now 15 in hexadecimal, sorry, 15 in, so 15 if you were to write it in terms of binary would give you 1, 1, 1, 1. All 4 bits are high. Hence, once you have transformed this using SBox1, this would be what? 1, 1, 1. Now you're going to pick up another 6 values, which is going to be 1, 0, 1, 1. What are the last 2 values? Most significant bits and the least significant, 1, 1. So based on our table, this is going to, now you need to, don't use the same SBox. You're going to go to a different SBox now, SBox2. So this is going to be still 3, and inside value, if you were to count it, so 0, 1, 0, 1. So this is 1, this is 2, 4, so this is 5. All right, 4 plus 1 is 5. So binary value that inside binary value, which is going to be your 0, 1, 0, 1, this equivalent to 5 in decimal value. So you will just simply go here, and so this is going to be 3, and this is going to be 5. So this is still 15. This is still 15. 3 and 5 is still 15 in this Xbox 2. So this is still 15. And this is how you're going to populate this. I hope you're getting it. And now I'm going to go back to my diagram. Go back to my diagram. I'm going to quickly look at what's going on. What is the next step that I need to do? Now these 32 bits will go to a box called straight P box. Okay, where is that straight P box? The straight P box is right here. It's right here. Now still you're trying to rearrange it. All the straight P's, expansion boxes, you're just trying to rearrange the bits. So 16, 7. 16, 7, 20. So the first position, the first bit, the newer bit is going to be your 16th bit. So let's just quickly look at it. So this was your data, and this is already highlighted after substitution boxes. So your first bit, this bit, is going to be your 16th bit. So what is my 16th? So this is 4, this is 4, this is 4, this is 4. So 0. 0 is my 16th bit, hence this will become my first bit after straight P box. Alright, so far so good. And this is how you're going to populate this. Let me just do one more for you. 7. So the second bit is going to be your 7th bit. So let's just look at it. So this, so what is my, so this is 4. So this is 4, 4, 4, 4. Oh, sorry. This is going to be my 7th bit. So this is just going to be simply 4 plus 4 is 8. So this is going to be my second bit, because you can clearly see this is after a straight P box. Now the next thing is, as per my table, let's just quickly look at our table. The next thing is, once this is out, this out is being XORed with your left bits. Alright, there are two things happening, guys. Once you have gone through your straight P box, this output is coming out from this function, and this is being XORed with your left hand bits, at the same time becoming your right hand bits. So there are two things happening, actually three things. The output of your straight P box is going to be XORed with your left hand bits, which you haven't done anything to. All the function that you have done is being done on your right hand bits. So it's being XORed with your left hand bits, and it is becoming your right hand bits. Alright, because it's going into a swapper. That swapper is converting, once you have XORed your left bits with this function bits, that is becoming your right hand bits. So this, all of this process is being done on that spreadsheet like this. So these bits are being XORed with my left hand bits, which I haven't done anything on it. At the same time, they are becoming my right hand bits. So what I'm saying is this: once I XOR these with these, and this will, the resultant will go here. That's all I'm saying. All right, it's being swapped like this. So let's just quickly look at the figure. So the output is actually being XORed with my left hand bits. Once my left hand bits, and then they are becoming, in going to a swapper, they are becoming my right hand bits. So let's just quickly look at it. So these are my right hand bits after being XORed. All right, after straight P, and they are going to be XORed together with these bits, and they are going to become my right hand bits. So let's just quickly look at it. So let's look at my 0 and 0. 0, 0 is actually 0. So it's right here. This is the answer. right? Now let's look at 1 1. 1 1 is going to be 0. Sorry, I'm sorry. This is second bit is 0 and 1. So 0 and 1, that is 1, which is right here. Now the third bit is actually your 1 and 0. So that is 1 and 0 is still 1. The fourth bit is 1 and 0. You'll get 1. Now let's look at the fifth bit. 0 and 1 is 1. Now 1 and 0 is 1. And so forth. Now let's see a change. Let's look at this. 1 and 1 is 0. So they are becoming your right hand bits, and so you're XORing them, and they are, these straight P bits are being XORed with your left hand bits, which you haven't done any operation to, and they are being swapped and they are moved to a position called right hand bits. So far so good. Now let's look at something else. What else is missing in this algorithm? Alright, so once these are becoming your right hand bits, now look, what are your left hand bits? What are your new left hand bits, which is going into round number 2? Now these are just the right hand bits, plain old right hand bits, that nothing has happened to it without any operation that is running on them. So these were, now if you were to look at it, these are the right bit as per the algorithm. These just becomes your left hand side bit as is, without anything on it. So all the operations start taking place on your right hand bits. They went through expansion P and all of those blocks, and they were being XORed by your left hand bits, and they are moved to your right hand bits, and your right hand bits went as is as well and become your left hand bit. So this is how this is how the round 1 will take place. Then only initial permutation, you will do initial permutation at the start of round number 1, and every single round you will repeat the same thing. You will repeat the same operation. Everything is going to be the same. You're going to make those diffusion and things like that, and based on this, and at the final round, before you do the output of that, that will have your final permutation at the end. As you can clearly see, I'll just show you. I have all of these rounds are working like this. So by simply changing, let me change the key first. Let me change the first 2 letters of the key. Instead of 1 2, I have AB. Now everything changes. Right? Everything changes about the algorithm. Your key changes and stuff like that. So you have a ciphertext, you have a round key that is associated with this ciphertext. So based on a single key, we are generating 16 individual keys, and as you will quickly see the shift that I just showed you using those spreadsheets. Remember, your right hand bits, initial bits were becoming your left hand bits for the second round. Look at this pattern. So this is like this. So just like in our spreadsheet, if you were to look at it, sorry, if you were to look at it in terms of a diagram, let's look at the diagram quickly. Look, for round number 2, so these are going to be your bits for round number 2. So right hand bits as is are becoming your left hand bits for second round. Now let's look at it. Isn't this what happening? Isn't this what is happening? Your right hand bits are becoming left hand bits, and the operation will start taking place on your left hand bits and so forth, as you can see. So in each round, only half of the bits. So one of the vulnerability of this algorithm was that it was only encrypting half of the bits in each round, as you can clearly see. But still, it took them like 20 years or something to figure it out how to even break the cipher. So I hope you like this small tutorial on the ES algorithm. We'll do a key expansion algorithm in the next video because it's getting lengthy. If you have any question, leave it in the comment section. Don't forget to like and subscribe to my channel. I will put a link on my video on these spreadsheets where you can go and download them and you can play around with these spreadsheets.